Hi, Assalamualaikum. Today we're going to learn about electronegativity. So what is electronegativity? Electronegativity is the property of an atom which increases its tendency to attract the electron of a bond. If two bond atoms have the same electronegativity value as each other, they share electron equally in a covalent bond. Usually, the electrons in a chemical bond are more attracted to one another, electronegative one, than to the others. The result in a polar covalent bond. If the electronegativity value are very different, the electrons aren't shared at all. One atom essentially takes the bond electron from the other atom, forming an ionic bond. Key takeaway: electronegativity. Electronegativity is an atom's tendency to attract electron to itself in a chemical bond. The most electronegative element is fluorine. The least electronegativity or most electropositive element is francium. The greater the difference between atom electronegativity value, the more polar the chemical bond formed between them. Moving on to periodic trend in the electronegative of element. As we move across a period from left to right, the nuclear charge increase and the atomic size decrease. Therefore, the value of electronegativity increase across a period in the modern periodic table. For example, the electronegativity trend across period 3 in the periodic table is depicted above. There is an increase in the atomic number as we move down the group in the modern periodic table. The nuclear charge also increased, but the effect of the increase in nuclear charge is overcome by the addition of one shell. Hence, the value of electronegativity decreases as we move down the group. For example, in the halogen group, as we move down the group from fluorine to acetine, the electronegativity value decreases and it is shown in the diagram beside. It is a general observation that metals show a lower value of electronegativity as compared to non-metals. Therefore, metals are electropositive and non-metals are electronegative in nature. The elements in period 2 differ in properties from their respective group, 11 due to the small size and higher value of electronegativity. The element in the second periodic show resemble to the element of the next group in period 3. This happened due to small difference in their electronegativity. This shown lead to the formation of a diagonal relationship. Moving on, most and least electronegative element. Most electronegative is fluorine. Fluorine is the most electronegative element on the periodic table. Its electronegativity value is 3.98. The least electronegativity. Cesium is the last electronegative element. Its electronegativity value is 0.79. Therefore, fluorine is the most electronegative element and cesium is the last electronegative element. Moving on, factors affecting electronegativity. There are three factors affecting electronegativity. First, effect of substituent. The electronegativity of an atom depends upon the nature of the substituent attached to that atom. The difference in electronegativity of an atom caused by substituent result in different chemical behavior of that atom. Second, nuclear charge. A greater value of nuclear charge will result in a greater value of electronegativity. Happen because an increase in nuclear charge causes electron attraction with greater force. Third, size of an atom. A greater atomic size will result in less value of electronegativity. This happens because electrons being far away from the nucleus will experience a lesser force of attraction.
Assalamualaikum and good morning. Assalamualaikum and hello everyone. Next, I'm going to talk about variation in electronegativity and I'm going to explain in two forms which are across period 2 and 3 and second is down the group 1 to 13 to 18. First, I'm going to explain the definition of variation in electronegativity. The definition is on the periodic table, electronegativity generally increases as you move from left to right across a period and decreases as you move down a group. As a result, the most electronegative elements are found on the top right of the periodic table, while the least electronegative elements are found on the bottom left. As I said in the previous slide, we are going to talk about the variation in electronegativity across group 2 and group 3. As you can see from this slide, there are two graphs, one being electronegativity of group 2 elements and the other being electronegativity of period 3 elements. So as you guys can see from group 2 elements, the electronegativity decreases. And this is because as the atomic number increases, the electronegativity decreases. In group 2, as the atomic radius increases, the outer electrons are more shielded from the attraction of the nucleus. This is so the electrons will be less strongly attracted to the nucleus. We can see the difference between both of these graphs, which is one of the graphs decreases while the other increases. 3, we can see the graph that shows the electronegativity varies upwards. This is because as the nuclear charge increases, the atomic radius decreases. This happens because there are more electrons, but the increase in shielding is negligible because each extra electron enters the same shell. So electrons will be more strongly attracted to the nucleus. For the second point, we are going to talk about the variation in electronegativity down group 1. Okay, in this slide, we can see the graph of electronegativity of group 1. Okay, you can see that as lithium, as it goes from lithium to calcium, you can see the difference between their electronegativity number. And this is because each of these elements has a very low electronegativity when compared with fluorine, and the electronegativities decrease from lithium to calcium. For a small summary of this slide, as the metal atoms increase in size, any bonding electron pair becomes farther from the metal nucleus and so is less strongly attracted towards it. This corresponds with a decrease in electronegativity down group 1. With the exception of some lithium compounds, the group 1 elements each form compounds that can be considered ionic. Each is weakly electronegative, that in a group 1 halogen bond, we assume that the electron pair on a more electronegative atom is pulled so close to that atom that ions are formed. And that will be the finish.
Okay, Assalamualaikum everyone. Right now I'm going to talk about electronegativity effect on bonding. As you guys can see, there are 3 figures shown on the slide. The first figures is electronegativity values. If you guys know that each element on periodic table has their own value, electronegativity difference from 0.0 to 0.2, the type of bond formed is non-polar covalent. 0.3 to 1.4, the type of bond formed is polar covalent. Greater than 1.5, the type of bond formed is ionic bonds. The presence of a polar covalent bond in a molecule can have some pretty dramatic effects on the properties of a molecule. Right now, let's move to figure 3, ionic bond versus covalent bond. Covalent bond has 2 types, which is non-polar covalent and polar covalent. Ionic bond. The ionic bond is the attraction between positive and negative ion in a crystal compounds held together by ionic bonds are called ionic compounds. If the difference of ionization potential between the 2 atoms is more, ionic compounds are formed. Atoms with greater electronegativity difference lead to the formation of an ionic bond. Covalent bond. Okay, what I said before, there has 2 types, which is non-polar and polar. The covalent bond is a bond formed when 2 atoms share 1 or more electron pairs. Each atom contributes equal number of electrons toward the bond formation. Atoms with higher ionization potential are unable to lose their valence electrons and hence prefer to form covalent bonds by sharing of electrons. If the electronegativities of the combining atoms do not differ much, then the bond formed between them is likely to be covalent. Right now, I'm going to tell you guys about non-polar covalent, polar covalent, and ionic bonds. A non-polar covalent bond. A non-polar covalent bond is one in which the electrons are shared equally or nearly equal between atoms. This means that there is an equal or near equal probability of finding the electrons near each nucleus. Consider the scenario in which the atoms that form a covalent bond are identical, as in H2Cl2. And other diatomic molecules. Since the electronegativity difference between 2 identical atoms is 0, the electrons in the bond must be shared equally. In the case of Cl2, each bond must be shared equally. In the case of Cl2, each atom starts off with 7 valence electrons, and each Cl shares 1 electron with the other, forming one covalent bond. A non-polar covalent bond is a type of chemical bond that is formed when electrons are shared equally between two atoms. Thus, in an atom, the number of electrons shared by the adjacent atoms will be the same. The covalent bond is also termed as nonpolar because the difference in electronegativity is mostly negligible. And further means that there is no separation of charge between the two atoms or both the atoms have similar electronegativity. This type of bond is also formed when atoms that share a polar bond arrange themselves in such a manner where the electric charges tend to cancel each other out. A non-polar covalent bond can occur between two identical non-metal atoms and between different atoms. Polar covalent bond. In general, a polar bond in a certain class of a covalent bond, we can also say that it is the dividing line between the formation of a pure covalent bond and ionic bond. However, if we want to define it more accurately, a polar covalent bond is a bond that exists between two atoms consisting of electrons that are unevenly distributed. Due to this state, the molecules tend to have some electrical dipole moment wherein the two ends are either slightly positive or negative. Electronegativity plays a major role in determining the different types of covalent bonds. Electronegativity is the tendency of an atom to attract a shared pair of an electron toward itself. It has no unit symbol, it is a tendency. The covalent bond formed between two atoms in molecules whose electronegative difference exists is known as a polar covalent bond. And last but not least, ionic bond. The electrostatic force of attraction which pulls the two oppositely charged ions together is called the ionic bond. A chemical bond is formed between two atoms by the complete transfer of one or more electrons from one atom to the other, as a result of which the atoms attain their nearest inert gas configuration. There are primarily three ways in which two atoms combine to lose energy and to become stable. One of the ways is by donating or accepting electrons to complete their octet configuration. The bond formed by this kind of combination is known as an ionic bond or electrovalent bond. This kind of bond is formed when one atom gains electrons while the other atom loses electrons from its outermost level or orbit. In simple words, electrovalent bond involves the transference of a certain number of electrons to another dissimilar atom which has a tendency to gain electrons so that both acquire stable inert gas configuration. The electrostatic attraction always tends to decrease the potential energy. Hence, the potential energy of the system is much less than it was before the formation of an ionic bond. Okay, from this slide, you guys can know that electronegativity have three types, which is non-polar bond, polar bond, and ionic bond.